Here's how we solve a system of linear differential equations with constant coefficient matrix. Here is the differential equation. Y prime equals the matrix times y vector. And the initial values are given -5, -13 for the two components of the vector valued function y. Previously, we have seen that the eigen pairs of this matrix are calculated as lambda equals to -8 eigenvalue with eigenvector 1, 3, and the other eigenvalue is 6 with corresponding eigenvector 1, 2. So that means the theory says that we obtain a fundament and a set of solutions for the system of differential equations if we write two vectors, y1 e to the -8t, -8 is the eigenvalue, times the corresponding eigenvector 1, 3. And the other solution, y2, is e to the 6t, where 6 is the other eigenvalue with its corresponding eigenvector 1, 2. Once we have a fundamental set of solutions y1, y2, then the general solution to the differential equation is y equals to c1 y1 plus c2 y2. This is how we write it out. And the c1 and e exponential, c2 and this exponential, these are scalars. So we can multiply the vector component by component, and then we can add together the two vectors to get these two components of the solution vector. This is an initial value problem, so we will also have to find appropriate values of C1 and C2. The way we find it is exactly the same as we did for scalar system, that scalar differential equations, it's just we substitute 0 into this solution vector for time. We take time equals 0, t equals 0, and we set it equal to the initial values given originally. We have these exponentials. Remember that e to the 0 is 1. So then we obtain this system of equations, and this can be written as c1 plus c2 equals -5, and 3c1 plus 2c2 equals -13. Again, we obtain two equations for two unknowns. Now, this should have a unique solution. One solution for c1 and c2. The way I solve this is that I express c1 in terms of c2 from the first equation. Then I substitute back this into the second equation for c1. Then we obtain an equation in c2 only. We expand, simplify, and we solve the equation for c2. In our case, c2 is -2. Once we have this, we substitute back into the formula for c1. Substitute this -2 for c2, and we get -3. So c2 is -2, c1 -3. We have the solution to the initial value problem with these values, and it's written in this form. And this is it. This is how we solve a system of two differential equations.